Hi, I'm Shuai from HKUST H7. I will present our work, Who Should I Trust, AI or Myself? Leveraging human and AI characters likelihood to promote appropriate trust in AI-assisted decision-making. With impressive advances, AI has been adopted in numerous domains, ranging from low-stakes tasks such as movie recommendation to high-stakes tasks such as medicine, criminal justice. However, AI is still far from perfect. Besides, due to legal and ethical concerns, it remains risky for AI to make a decision autonomously. Hence, AI usually performs an assistive role by providing a recommendation, while the human decision maker can choose to accept or reject AI suggestion in the final decision. In this paradigm, one critical challenge for the human decision maker is to know when to trust the AI and when to override the AI suggestion. Usually, AI models can output a prediction along with a confidence score. A well-calibrated confidence score can represent the AI's actual correctness likelihood on that prediction. So existing methods try to calibrate humans' trust only based on AI's confidence, such as making humans doubt AI if AI's confidence is lower than precise thresholds. However, these methods overlook humans' own correctness likelihood. This poses the question, when AI's correctness likelihood is low, but the until humans is even lower, should we still encourage humans to doubt AI? To explore this question, we propose a framework that promotes humans' appropriate trust at the task instance level by comparing the correctness likelihood of both sides. The first part of this paper is to model human correctness likelihood on a given task instance. Inspired by research in cognitive science, which suggests that humans make decisions by weighing similar past experiences, we propose to estimate human CL at a new task instance based on their past performance in similar task instances. However, it is often difficult to obtain humans enough historical decision data, especially for new tasks. Therefore, we propose a method to first approximate humans' decision-making model, which is a mapping from task input to human prediction, and then applies the model to estimate human CL on any specific task instance. Before going into details, let's first look at task. We choose income prediction as our test bed, and we use logistic regression as the AI model, which can output well-calibrated confidence scores by default. We also selected 40 task samples and divided them into two batches. Each batch of samples fulfills multiple criteria, such as human and AI have comparable performance on these samples, and we calibrate AI confidence to make sure it corresponds with AI's actual correctness likelihood. How to effectively approximate a human's decision-making model? First, we gather human's decision data on a small number of task samples. Second, we fit a classic decision tree model to infer human decision-making models and generate initial decision rules. Third, we design an interactive interface for users to modify the initial model to make it better align with their actual decision-making process. Once we approximate a human's decision-making model, the final step is to apply the decision model to estimate the human's correctness likelihood in any specific task instance. For a new task instance, we first retrieve its neighborhood instances in the training set. Then, we apply human's decision-making model to compute human's potential performance on these task instances. And finally, we use a distance-weighted method to estimate the human CL for the new task instance. We conducted two preliminary studies. In the first study, we explored the appropriate interface for humans to craft their decision-making model. And we found that compared with interactive decision tree, interactive rule set is more appropriate to represent human decision processes and is visually simpler for them to digest. In the second study, we verified the effectiveness of our method in identifying complementary regions where only one member of the human AI team can make correct predictions. Results show that our human AI CL-based method outperforms the traditional AI confidence-based method. In the second phase, we explore how to communicate the model human AI correctness likelihood to empower the AI-assisted decision-making process. We aim to investigate two research questions. First, how do different CL exploitation strategies affect human trust appropriateness and team performance? And how do different CL exploitation strategies affect humans' perceptions and user experiences in the decision-making process? Let's take a look at our experimental conditions. The most intuitive mechanism is called direct display, where we directly present the estimate human and ASCL and the AS recommendations to the human. Based on IQ bias and cognitive forcing theories in decision-making, we propose adaptive workflow. In this condition, if the predicted human cell is higher than AS cell, our interface will first ask human users to make their initial decision before seeing AS recommendation. Otherwise, our interface will directly present the AS recommendation to the human. We also propose adaptive recommendation, where the AI shows the explanation by default. We control the display of AS recommendation based on human ASCL, and AS suggestion is only shown when ASCL is higher than the humans. We compared our proposed interfaces with two baselines, human only, and AI confidence, which is strong baseline used in existing work. For the study design, participants first finish 20 tasks and then modify their decision-making models, and finally, they finish the last 20 tasks. We recruited 293 participants from prolific with strict qualification criteria. For details, please refer to our paper. We conducted mixed method analysis. For RQ2, we mainly measure the human-AI agreement and team performance. For RQ3, we mainly measure perceived complexity, mental demand, satisfaction, and perceived usefulness. We also collect open-ended questions to understand participants' mental processes and experiences. Now, let's take a look at the results. We first show the effects on team performance and human trust appropriateness. The proposed 3CL exploitation conditions achieve complementary performance, while the AI confidence condition did not. And humans in the proposed 3 conditions trust the AI more appropriately than AI confidence baseline. For example, when the AI's recommendation was wrong, the human-AI agreement was significantly lower in 3 conditions. In summary, the human ASCL-based methods reduce humans' overtrust in AI without inducing significant undertrust. Please check out our paper for other interesting findings. We also investigate the effects on humans' perceptions and experiences. Overall, our 3 proposed conditions did not lead to significant differences in participants' perceptions except the perceived system complexity. Specifically, we found that although adaptive workflow achieved the highest team performance, the benefits came from increased system complexity and mental demands. Therefore, we suggest future work to explore the trade-off between effectiveness and user experience. We also analyzed how participants perceived, used, and were affected by the human ASCL. Results show that some participants doubted the displayed CL information and ignored it in the decision-making process, but most participants referred to or were influenced by displayed CL or CL-based adaptation. And the participants in adaptive workflow and adaptive recommendation conditions were forced to think independently. Please check out our paper for detailed findings. Finally, we provide some implications for human-compatible AI-assisted decision-making. First, cognitive bias is not always harmful. Sometimes we can leverage humans' cognitive biases to facilitate human-AI teaming. Second, maintaining proper self-confidence is critical for humans to establish appropriate trust in AI. However, prior work only focuses on confidence calibration on the AI side instead of the human side. Third, humans' understanding of numerical probability affects the effectiveness of trust calibration, so try to avoid directly communicating numbers to lay people. Moreover, exploiting knowledge or capability complementarity beyond trust calibration is beneficial and even more critical for achieving complementary human-AI team performance. Please check out the paper for more implications. Thanks for your attention. Welcome any questions.